In this class, we're going to build a traditional four-poster bed with a contemporary twist. Now, this piece was designed by Glenn Anderson, who's a very talented furniture designer. Glenn studied architecture at UNLV, and he often draws upon that experience in his design work. Well, let's go ahead and get started. Now, when it comes time to make the post, you have two options. The first is to just take router bits and arbitrarily position them, set your bed, and make cuts on the fly. A better alternative is to use the optional design kit. As you can see here, we were able to lay out every detail on the plan before we started making the cut, including which router bit, the position of each cut, the depth of the cut. We even calculated the adjustable bed when it comes time to cut these tapers. This design has both straight tapers and this curved section here. The design kit makes it easy to lay out both. In fact, we'll use the design kit to create the templates to mill this contoured profile. Now here's the finished part, as you can see right here, and we're going to machine these parts for the headboard, where this is the footboard. So these are a little bit longer, but it's the same basic design, and of course we'll cut these taper and details in this section here. At this end, you notice that we've got the big flare, and so we're going to glue up extra stock onto this end. We started with 8/4 stock, and we ran that through the joiner so that we could glue these two pieces together to make our square blank. We then ran that through the joiner and the planer to make it 3.75 inches square. Now, we have this big flare on the end, so we're going to add extra material here, as you can see. We glued on the two pieces here, and then we machined this off so that it was flush with this surface right here, and then we'll glue on this next blank. So the first step is to machine these like you see here. We're going to use the model 1200 for this project because it's long enough to do these posts in one section. As you can see, we have removed the dust bag. That's just to make it so that you can see more clearly what's happening as we're making these cuts. Normally, you would put the stock between centers and you'd use the indexing pin and an indexing plate to mill the square sides. We're going to show you an alternate technique that works really well for this type of project. Now, this section here at the end is actually 3 inches long, and it's put here so that we can clamp it in the horizontal vices. That keeps the part perfectly level in the bed. When we're finished with this project, we'll come back and cut it off right here at this point. Also, we're going to use the spindle shaft here as a stop. So we'll slide this in until it just butts up against the spindle shaft here and clamp this part in place. So we'll clamp in this end, and then we'll also set the clamp here at this end and lock that in place. Now, obviously, the bed has to be set perfectly level as we machine this surface. We have the optional Z-axis on this machine, so it makes it very difficult to film and see what's going on. I'm just going to flip the machine around here so that you can see it from my point of view. We're going to plunge the bit down until it just rests on this surface. Now we'll set that stop on the Z-axis, and then we'll start cutting on the back side. Now you'll notice I cut from the left to the right on the back side all the way through, but the very last pass was from right to left, and that avoids any tear out here on the edges. Now you may want to sand off that surface just a little bit to make sure it's perfect. Now we've finished this surface, we'll just open the cams on the horizontal vices, and we can take this part out and rotate it 180 degrees. Now we just bring it up against the spindle shaft. That acts as our stop. Everything's going to be aligned properly. We just close down our clamps. Now we've glued on these parts on the top and the bottom on both pieces, and we'll just let this dry, and then we'll throw it in the machine and start cutting. Now we've used the mill to machine these two end blocks square. Obviously this would be very difficult to do with either a joiner or a planer. That's one of the advantages of doing it on the Legacy. Okay. Now if you don't have a joiner or a planer, all of this could have been done on the ornamental mill. Obviously it's not going to be quite as fast, but it will be very flat and true. Now at some point we're going to cut this contoured section right here out of this block. But we're going to show you a couple of methods to waste a lot of this material. We'll use the template to mark where we want to make the cuts. We set the template flush with the end. Then we use a straight edge to line up the edge of the template and draw the line. Using the bandsaw, we cut outside the line, leaving approximately 1/8 of an inch of material. Remember, this is a rough cut, just to remove the extra material. The final cut will be made on the Legacy. After cutting off the two sides, we taped the pieces back onto the blank and rotated the stock 90 degrees to make the final two cuts. If you don't have a bandsaw large enough to make this cut, or you simply don't want to fight with a blank this large, we'll show you an alternative method of removing the stock on the Legacy ornamental mill in an upcoming lesson. Now we're ready to start milling the post. Looking at a drawing, we have a straight tapered section from here, ending at 24.5 inches, starting at 11 on a drawing. So that's a 13.5 inch span. The difference in the width is 1 inch. Now you refer to your tapering chart, you'll see that on the 1200 we want to raise the bed 3 inches at one end. Now we'll raise the tailstock end 3 inches higher than the headstock end, and of course we'll need to double check both sides to make sure that they're even. And now we've got it set up for the tapered section. Now looking at the drawing, you'll notice that the end of this flat right here is at 24.5 inches. But keep in mind that the router bit itself is 1.25 inches wide, so we'll set a stop here on the x-axis at 23 7/8 of an inch. Now we've also set a stop at 11 3/8 of an inch, and then we'll set our plunge depth so that the router bit just rests on the surface of the wood. Now we'll set this stop and zero our scale. When we start cutting at this end, we'll be cutting on the surface or at 0. But when we get down to this end, we'll be 1/2 inch deep, and that's too much material to take off in one pass. And so what we're going to do is raise the router. And keep in mind, each turn of this handle is 1/4 of an inch. So if I turn it turn and a half, that's 3/8 of an inch, and we can start cutting down at this end. Now we plunged down 1/8 of an inch for each pass, so it took 4 passes to cut that tapered section. Now we'll go ahead and release the clamps, and we'll rotate this stock 90 degrees. Now just make sure we bring it up to the spindle shaft each time. That's your stop. That ensures that we always mill to the same position. Again, we cut across the face here to begin with, and then machine this tapered section. That gives us a clean edge here with no tear out. You can see it's coming together here quite nicely. This tapered section matches this tapered section right here. The next step will be to cut this tapered section on the top, and then we'll add this detail here as well as the indexed cuts to form the reeds along the length here. The last process, or the last step, will be to cut this flare. Now when we made our first post, you'll notice the section that comes through here to clamp on is only 1 inch long. Well, what happened then is we had to create a little spacer to put in here to set that off correctly. On the second set, we learned a lesson, and we made this section 3 inches long. That way we eliminate the spacer, and then the horizontal vices here will hold the parts very securely. Now the next step will be to set the bed in the opposite direction to cut this taper on the top section. On the footboard, these posts were a little bit shorter. This span was 30 inches long, and the difference in this width is 1 inch. So referring to our tapering chart, we adjusted the bed 1.25 inches for this particular part. On this part, this stretch is longer. It's 44 inches instead of 30. It's still going to be 1 inch difference from this end to this end. So looking up our tapering chart, we found that we needed to adjust this end 1 inch higher than this end. We set the bed back to level. Now we'll raise this end 1 inch. And of course you'll want to check the other side as well. Now just a side note, we get a lot of people that are asking us about the z-axis and what its advantages are. Right here is a perfect example. On this particular part, this base is so large that we have to drop the bed down quite a ways. The smaller diameters here, consequently, are so far down we can't reach them with the standard plunge router. With the z-axis, we have the extended plunge range to give us that depth, and we don't need any collet extensions or anything like that. Plus, you have the digital readout here so that you can make micro adjustments to your depth. Referring to the design kit, we see that the end of this cut right here is at 26 inches. Keep in mind that the router bit is 1.25 inches in diameter. Therefore, the center of the router bit will be back here 5/8 of an inch. So I set this stop at 26 5/8 of an inch. We'll set the plunge depth the same way as we did at the opposite end. We're going to refer to this end of the stock, and we'll just bring the bit down till it touches the surface. Now I'll go ahead and set the stop right there and hit 0 on my digital scale. Obviously we can't make this cut all in one pass. At that end it'll be 1/2 inch deep. So what we'll do is we will raise the router 1.5 turns, that's 3/8 of an inch, and we'll make an 1/8 inch cut for each pass. Also, I'm going to bring it to the front side of the machine for this pass, because as I cut through this bead, I don't want to get any tear out. For more information on tear out, you can avoid to your training DVDs or to the online techniques. The next step is to cut these reeds. We'll use a side reeding bit and run the bearing on the surface of the wood, and you'll notice that it wraps right around the corner over the end of the post. We've marked the center part here and set the router bit so that it cuts right on the center line. Now we'll hit 0 at this point, and then we're going to raise it 0.375. We'll set the stop right there at that point, and then we'll start cutting back here at 27 inches, and I'm going to put a stop here to control the length of that cut. Once the first cut is complete, then we'll release the clamp or the stop and lower this down to 0, which is 3/8 of an inch deeper. Then we'll set that clamp and make the next cut. Wow, that looks nice. Again, two advantages of the Z-axis is number one, we can plunge down to this depth, which is quite deep. And number two, using the digital scale, we can make that adjustment 0.375 or 3/8 of an inch and be within 1/1000th of an inch. Now this class was fairly simple. All of these cuts are straight tapers. In the next class, we're going to take on the flare here at the bottom. This section creates a real challenge. It has this nice graceful curve to it, so we're going to have to use a template. However, it is so wide or so deep that you can't cut from the side with a flush trim bit. So in the next class, we'll show you a few tricks for handling this type of work. In this third class, we're going to show you how to cut this flare at the base of the post. Normally you'd use a flush trim bit for this operation, and Magnate has one that has a very long shank so that you can plunge down very deep. Although when we look closely at this part, you can see as we plunge deeper and deeper, we are still going to run out of router bit, even though we're using the Z-axis on the machine. So we can't cut on the side as we would traditionally do with a template. For this technique, we use a couple of locking plates, which we'll insert inside the bed rail and mount the template vertically, as you can see here. We'll start by mounting the stock into the horizontal vices, and then we've attached the template right here. It's critical that we line up the edge of the blank here with this line on our template. And then we're going to use a straight edge and simply place it across here so that the height of the template is even with the top surface of the post. Next, we'll make the bottom of the template parallel with the bed rail as shown here. This is the side that we roughed out with a bandsaw, but when we did that, we told you we would show you an alternative method. So we've saved one side on this blank. Before making the final cut, we're going to show you how to waste this material on the mill. To quickly remove the material, we'll use a 2-flute straight cutter, 1 inch in diameter. We'll start off by positioning the carriage at 11 inches. That'll put the center of the router bit right at the edge of this block. Then, of course, we'll need to set our plunge depth, and you don't want to take off too much material at a time. Probably 1/4 of an inch would be the max. And we'll just waste this material continually lowering the bit until it gets down close to the template. Just make sure that you never go as low as the template as you cut along this edge. Now it's roughed out, ready to cut the final profile. In the past, when we've shown how to use a template vertically like this, we used the 2-inch diameter core box bit. However, we found that the crown molding bit has a much more gradual curve, and so it requires less sanding once we're finished. Before we begin cutting, let me just explain the process real quickly. We'll start by putting the router at 11 inches, right at the edge of that cut. Then you'll take this router bit and turn it parallel to the template, and you'll plunge down till it just touches the template. Then you'll make a cut across the face. Next, you'll reposition the carriage 1/4 of an inch or 1 turn. You'll lift the bit up, bring it back here, and then plunge it down till it touches the template and make your second cut. And repeat that 1/4 of an inch each time all the way through that process. It's important that you turn the router off, obviously, when you bring it down here to set your plunge depth. Now we have that profile cut. We'll go ahead and just touch it up with a sander. Well, that completes the post for both the headboard and the footboard. In the next class, we're going to show you how to cut the joinery and the rails, and then we'll come back and trim off this base piece. Now we started by setting up all 4 posts with the frame so that we could select the surfaces or the sides that we wanted to show and put those out. And then we take a pencil and simply mark where we want to make this cut. We have made 3 cuts on 3 of the posts. We just have this one left. So we'll mark this side right here so that we'll know which side to cut off once we put this post into the machine. I've mounted the part into the machine with my mark on the top surface like this. This mark that I made on the post is not necessarily in the correct position. It's just a reference so I'll know which side to cut. You remember that we had the end of this part lined up with 2 inches on our x-axis scale. We want to come up 7 inches from this end to start the cut and make a cut 5 inches long. So on the measuring tape, this would actually start at 9 inches. Remember, the router bit is 1 1/4 inches in diameter. So if you positioned the pointer exactly at 9, it would be cutting too wide by 5/8 of an inch. So we set a stop in the x-axis at 9 5/8 of an inch. That way the edge of the bit will be lined up at 9 inches on the measuring tape. This flat is going to be 5 inches long, so I'm going to slide the router down the 5 inches and then back 5/8 of an inch because of the diameter of the cutter. And this edge right here is where we'll begin the cut. Now I won't need a stop set here on the x-axis because we're simply going to start our plunge depth at that line and cut back. Anything past that won't cut on the wood at all. Again, we'll set the plunge depth right here. We'll cut only to the center line of this part, and it'll come down 5 inches and cut that out. Now I've marked the center line of the part, and I'm going to bring the router bit over until just the edge of the router bit is lined up at that position, and then we'll set a stop in the y-axis. Now I'm going to position the router bit along the x-axis so the bit is right at the end of the cut, and plunge it down until it just touches the surface of the wood. Now we'll set that stop on the z-axis, and we're ready to make this cut. I'm cutting on the back edge, so I'll cut from left to right so it climb mills on the corner and doesn't tear out the wood. Now that router bit gives us a rounded corner, so I'm going to use a chisel just to square up the corner of this cut. Obviously, this router bit has a very large radius. Now, if I used a smaller router bit with a tight radius, I could machine that out, and it would require less work with my chisel. Well, that completes the 4 cuts here to receive the frame. Now, we won't actually mount the frame onto this yet. We still have to cut the bottom of these posts off, and we won't do that until after we've cut the mortises for the rails. And we'll do all that in the next class. Well, in the last class, we machined the flats for the metal frame. Now what we're going to do is lay out to mount the hanger bolts, and then we'll cut the mortises for the rails. So we'll just lay these corner brackets right onto that flat surface and flush with the bottom edge. And then I'm going to take a pencil and just mark the position for these hanger bolts. And then we'll drill a hole right in the center of those slots. I'm going to use a 1/4-inch diameter router bit to drill the holes for the hanger bolts, and they'll go right here in the center of these slots. And this is a 1/4-inch shank, so it'll require a collet reducer so that we can put it into the eliminator chuck. By machining these holes in the mill, we're ensured that the holes are perfectly straight up and down. We'll take this router bit and simply plunge it down until it's just on the surface of the wood. Locking the x-axis onto the lead screw ensures that we can position it where we want it, and it'll stay there. We'll position this approximately in the center of the slot. It's not critical that it's perfect. That's going to be close enough. We'll lock that down with a stop so the router won't move in the y-axis. Now we can go ahead and drill this hole. Now we'll finish drilling these holes with a hand drill to get to the proper depth. Now we've rotated the post 90 degrees so that we can cut the mortise on this opposite face right here. And there are two methods for aligning the cut. Let me show you those real quickly. On the design kit, we laid out the post with this base at 2 inches on our tape. And we came up 7 inches from the base, so this actually measures at 9 inches. Then we come up 1.5 inches from this base to this point. So that would be at 10.5, and then 4 inches, so this would be 14.5 inches. So you could simply set your stops on the tape and machine down the center to cut this mortise. Or you can do like we did here, actually lay the mortise out with a pencil and then simply machine to the lines. The first step will be to set the plunge depth. So I'll plunge the bit down till it just touches the surface of the wood, and then I'll move it off in the y-axis here, and we'll drop it down 2 inches. And then set the stop. Now we can raise that back up and set our stops to limit the movement of the router to cut the mortise. So I've set a stop at both ends in the x-axis and also on the y-axis to keep the router bit down the center of the part. We use just a 2-flute straight cutter to machine the end perfectly flat, and then we'll come back with this Japanese pull saw and just trim this part off the bottom. Now we'll use a hanger bolt and just thread that into the post, and then we'll be able to put a nut on here to attach it to the metal frame. Well, we're getting close to finishing off this bed project. The next step will be to attach the rail between the two posts. And this is going to present a little bit of a challenge. We obviously have the mortise and the tenon, but the shoulder of the tenon right here has to match the taper on the post. And it has the slight flare here at the bottom. So when we butt this up tight, we'll have a good seam. Now we've attached the post to the metal frame. For this next step, we're going to measure the width of this rail, and we'll want to measure right in the middle of the mortises that we cut. This is measuring 57 inches What we'll do is add 1/8 of an inch. That will make sure that we don't make it too tight. We can always open it up just a little bit. One of the nice things about this frame is that it has slots here, and that gives us a little bit of room to play with on that measurement. And we've cut the rail 7 inches wide and 64 inches long, and we've mounted it into the machine with the horizontal vices. Next, we're going to set up the template. To lay out the template, we're going to use the design kit. We used it originally to cut the template to make this flare on the post. We'll use the same section to create the tenon, or the shoulder for the tenon on the rail. Now the rail is going to come in, it's going to start right here, and it's going to come up 7 inches. For the template, we're going to need an additional 3 inches to mount it on the machine. And I've added 3 inches on each side. So we'll use this section right here to lay out the template. I'm just going to take a sheet of paper, and I have darkened this line in with ink so I can see it easily. And I'll tape that down with a little masking tape. We don't want to simply trace this by hand because we want the template to be perfect. When we laid out the design originally, we used this French curve, so we'll use that so we get exactly the same curve, and then we'll just use the edge of the template here to give us the straight tapered section. Now it tapers down to this point right here, so I'll make a little mark here on the paper, and I can see that mark underneath, so I'll just line up the straight edge here to lay that out. Then this section is going to pick up that tangent and meet up with this corner right here. So now that profile matches this one exactly. We laid out a couple of other reference points on here as well, so let me show you how we do that. From this edge, we come up 3 inches. That's the actual edge of the rail. We'll mark here the edge of this rail. This is actually the edge of the template, 3 inches past here. We'll cut this section here off, and I've marked the center line of the rail itself. Now, we would take and cut this out with a pair of scissors, and then go ahead and tape it onto this board. This is a piece of 3/4 inch MDF, wide enough for the template, and about 16 inches long. The length is not really that important. Now what we'll need is a mirror image of this template to cut on both sides of the rail. So I'll take another piece that's exactly the same size, and we've put some double-sided tape on here, and we'll tape this down so when we cut this template, we'll cut 2 of them exactly the same. Now those 2 pieces are taped together. We'll go ahead and use a bandsaw and cut out this profile, but we'll cut above the line and then sand to the line so that it's perfect. Now whenever you're using MDF, of course you want to use proper protection for your lungs and your eyes. The straight section here, of course, can go right up against the sanding disc and keep that perfectly straight, and then we just need to flare that bottom end. Now this line is going to come even with the cut here. That'll be the bottom of the rail, and we'll test it to make sure it looks like it's going to fit perfectly. Remember, we need a mirror image of this template. So the next step will be to split these 2 apart, and then we'll flip it over, and we'll use some more double-sided tape to stick these 2 together, and that will create our mirror images with the holes drilled at the bottom. Now we'll stand this template up on its edge here. We'll put this edge down so that's the mirror image, and this will keep the edges perfectly parallel and flush, and then we'll just align the back of the templates here to stick them together. This center mark right here will be perfectly flush because that's the center of the template, and it lines up just like we wanted. Once that center line is marked, we don't need this template any longer. We'll go ahead and lay out a couple of holes to mount this to the machine. I've measured 1.5 inches, and I'll just scribe a line along that edge. The measurement for the hole on the back corner opposite the template is very critical. This dimension needs to be 1.25 inches. So I'll scribe that line there. The next one is not so critical. I'm going to set it at 10 inches. Now we'll go ahead and darken in these marks. And then we'll use a center punch to mark those holes to drill them. It's important that when you drill these holes, use a drill press and don't do it by hand to make sure that they're perfectly straight. And we used a countersink here to set this up for the screws, and this will mount here. You can see we have the mirror image that will mount in the exact same location. I've mounted the 2 brackets here to the template, and we'll put this first piece on. It doesn't matter which template you start with. But what is important is that you mount this template flush with this bracket right here. We'll also want this parallel with the rail. The easiest way to do that is to use a piece of 3/4 inch MDF and put that between the rail and the template. Again, line this up with the edge of that rail and lock it down. The reason we line it up with that is so that when we take this off and put the next one on, it will also line up with that, and that ensures that they're positioned correctly. Now I've laid out this end of the rail so that we can align the template. Let me show you a close-up look at how we do this. The rail is 64 inches long, and we want the shoulders to be 57 1/8. So we'll need to split the difference. We have 6 7/8 of an inch here, so what I'll do is measure back this way 3 7/16. Make that mark, and then of course I drew that line across. We also drew a line here centered at 3.5 inches. So when the router bit is sitting right here, flush with that, lined up with the center of the board, it will also be lined up with the template. When we built the template, we laid out the center line at this point. So when our stylus is centered right here on this line, the router bit should be centered on the center line of the rail. Now we cut a spacer to put between the spindle shaft and the end of the rail so that each time we put the rail in, it will end up at exactly the same position. Now the stylus is 1/2 inch in diameter and is going to run along this edge here. When it's centered on that line, the router bit needs to come right up to that mark that we made on the end of the rail like this. So I'll put the 1/2 inch stylus into the block and lock that down, and we'll line it up with that line and then check that the router bit is lined up with this line. If not, we'll adjust the template forward or backwards to get it to the correct position. With the router bit lined up with the center of the rail, the stylus should be centered on this line on the template. If you need to adjust the position of the stylus to line it up with the center line, you'll simply make adjustments on these screws here. Now we've got our template set up, we're ready to cut our tenon. Before we do that, we'll need to determine the plunge depth. So I'm going to use a set of dial calipers and measure the thickness of this rail, and it is measuring 0.810 inches. So it's measuring 0.810, and we want to have the tenon 0.500, or a ½ inch thick. So we'll take and minus this, we come up with 310 thousandths, or 0.310. Now if you divide that by 2, you're going to come up with 0.155. So we'll need to cut the shoulder 0.155. So I'll plunge the router down until the bit just touches the surface of the wood, and then I'm going to hit 0 on my digital scale. Next, I'll move the router off the wood, and we'll lower it down till it reads negative 0.155. Now we'll set the stop in the Z-axis, and then we'll put in the stylus and lock it in place. Next, we'll make sure that the split nuts are open so that the router can float, and we'll go ahead and make our cut. Again, we'll use the spacer to properly position the rail and lock it in place to make the next cut. Before I cut this end, I'm going to measure it just to ensure that it's the same, which it is. And then I'm also going to take the router bit and plunge it down and hit my 0 again to make sure that it's perfect for this side. Now I'll make the adjustment to 0.155, and we'll go ahead and make this next cut. Next, we're going to cut in here until the tenon is only 4 inches wide. The center of the tenon is at 3½ inches, and so we'll come over 2 inches on this side and 2 inches on this side, and we'll cut out this section here and this section here, again following the template. We'll drive the router bit over to the line, and then we'll set a stop right here on this side. Put the stylus back in place, and now we'll go ahead and make this cut. I'm going to use the Y-axis to control this, and we'll do it in 2 passes. Now we'll repeat that on the top side. So now we have a 4-inch wide tenon with a shoulder that'll follow the contour for the post. We'll use a chisel to square out these corners here, and then we'll just simply sand these round to match the mortise.
Yes.
On the post, we cut the mortises 2 inches deep from this top edge. So I'll measure from right there. We'll go to 1 7/8 of an inch, so we'll have an 1/8 inch for glue space. I sanded the shoulders of the tenon round to match the rounded mortises, so we can go ahead and test fit this. All right, that looks pretty good. I think we're ready to glue it up and finish it. This is the rail for the footboard, and of course we could just leave it like this, or we could do a simple edge treatment on this piece. What we're going to do is we're going to lay down a piece of molding and cap it on the top, and then put a piece of dental molding here in the front. So we'll work on that next. We've mounted a table into the bed here, and then we've attached the stock with double-sided tape. Now this piece is 2 inches wide, and it's a little bit longer than our rail, so we can come back and trim it after we've finished it. I'm just going to mark the board right here in the center at 1 inch, and we'll mill out this section right here, and then come back and chamfer these 2 edges. I've installed bit number 2704, which is the surface planing bit, and we'll bring that cutter up and line it up so that the edge of the cutter comes up against the line. Then I'm going to set a stop here in the y-axis. The router bit is just touching the surface of the wood, so I'll go ahead and zero out my scale right here and bring the router off the front of the wood and lower it down to 0.4 inches. And we'll go ahead and set the stop. With the stop set at 0.4 inches, that's our final depth, we're going to make this in a couple of passes, so we'll simply raise the bit up and make our first cut. Now we've switched to the V-groove bit. This router bit, along with all the rest of them in this project, are taken from the professional router bit set. We go ahead and put this in. We'll need to reset the y-axis. Let's go ahead and move this stop. And now we'll adjust the position of this bit so it's just going to chamfer that edge. Once the router bit is positioned where we want it, we'll go ahead and set the stop again. Next, we're going to cut the denticulation, but only into the center section of this molding. So we're going to measure this and make a reference mark right here in the center. We decided to use the 1/4 inch diameter 2-flute straight cutter to make this dental pattern. This is the only router bit that's not in the professional set. If you want to, you could exchange this for the 3/8 diameter cutter that is included in the set and make this molding. It would just make a wider cut. Now we're going to set the y-axis so the edge of the router bit is right on the top of that chamfered edge. We'll go ahead and set the stop at this position here. I'm going to lock the carriage down on the x-axis lead screw here at the center mark. With the y-axis, I'm going to open the split nut so that it can just slide in and out like this up to our stop. Now we'll go ahead and set our plunge depth. We'll plunge the bit down till it just touches the surface of the wood. Now we'll zero our scale, and then we'll slide it off the front and plunge this down 1/8 of an inch, or 0.125. Now go ahead and set the stop for the z-axis. The process is we'll simply slide this in and make a cut, and then we're going to move it over 1.25 inches to make the second cut. And you have two options. You can either open the split nut and slide it down the 1.25 inches and lock it back down, or you can simply turn the handle 5 turns and make the cut. We started right here in the center of the part, and we milled out 15 inches in this direction and then back 15 inches in this direction to give us a total of 30 inches. Next, we're going to trim the molding the length that we need with this in the center. Let me show you the assembly for the rail on the footboard. This is the rail itself, and of course we've already cut the tenons on the end, and we've cut the dental molding, which will be attached to the top of this rail. And the ends of the rails have been cut to match the angle of the shoulders. Then this rail will simply cap the top of it and be mounted like so. Now we cut this piece for the headboard 9 inches wide. We've cut the angle that we want on the ends, and now we're just going to use a router bit with a bearing. It's a V-groove cutter. And we're going to chamfer this edge right here. For the headboard, we wanted a very simple design, so we just went with the chamfered edge like you see here. We chamfered the edges of these rails, and we've mounted it to the headboard. If I flip this around, you can see we've just used some screws to attach that at this point. Now, the nice thing about this design is that it's going to appear as though the headboard is floating when we put it on the bed, and it's interchangeable. We can replace this piece anytime we want. Well, we've done our final dry fit. Everything's gone together, it looks nice, so we're ready to go ahead and sand this and put the finish on. Before we do that, let me show you how to adjust the headboard. You can see we've just temporarily clamped it in place here, and we'll adjust this for the final height according to how thick the mattresses are, and then we'll bolt that to that rail to make it permanent.